Well, hello and welcome, class. Lately in class, we're in kinematics. We've been doing some graphing of different types of motion, and what's intended to be a pretty simple idea has scared some people. So hopefully this video is going to go through and clear up some misconceptions and quell those fears. So let's get ready. Grab your safety glasses. We're going to do some learning. Some things could get messy. I can't see with these on, so I'm going to take those off. But keep yours on at home. Safety first, right? So like I said, we have been doing kinematics, and we've got these different types of motion graphs. So this one here, this is a position time graph. So position time graph, that just means that position is this vertical axis, time is the horizontal axis. Time is on the horizontal axis because it's the independent of those two variables. Time's going to go on no matter what. Very deep and philosophical, I know. That's a position time graph. Here we've got a velocity time graph. And this one is an acceleration time graph. In your position time graph back over here, all this plots is that any point in time you can find an object's position. Velocity time graph, for any point in time you find the object's velocity. Acceleration time graph, at any point in time you find the object's acceleration. Okay, pretty straightforward and simple. Let's go through and do some examples of these. As we're doing these examples, I'm going to go through and I'm going to do the simplest examples of every type of motion that we would talk of in class. So I think, from what I'm remembering, there's 7 different types of motions we might come in contact with. Sometimes, though, real motion in life is more complicated. It's made up of several types of motion, right? You speed up, you go at a constant velocity, slow down, go in reverse. That's complicated, but we can break it down into simple types of motion for each of those parts. So let's start at the simplest and we'll get more complex from there. Simplest type of motion would be that you're just at rest. You're not moving at all. And that's going to look like this. Okay? At rest. I'm at some position here this is some positive position, and I'm at rest. I'm not moving at all. I stay in that same position that whole time. This would look the same if the line was here or down here. This would be at a negative position. Regardless, I'm at rest. This is a completely flat line, not moving at all. If you're not moving, you're at rest, then your velocity is 0. Okay? You're not moving. You're going 0 meters every second. Another way to think about this is that the slope of this line, your slope in a position time graph, is your velocity. So the slope of this line is 0, so that makes your velocity 0. Good. Let's think about acceleration here. Is your velocity changing? Acceleration is the change in velocity per unit time, so it's how does your velocity change over time? Does this velocity change at all? No. No, your velocity doesn't change at all. So if the velocity is not changing and the slope isn't changing, the acceleration is also 0 because the slope of your velocity time graph, this is your acceleration. So if we have a velocity of 0, a change of velocity is 0, then the acceleration is going to be 0. Okay, I think that's the simplest case. You see how the position time graph, the slope of that is the velocity. In a velocity time graph, the slope of that is your acceleration. Let's move on to a little bit more difficult case. Here we've got another position time graph. Let's say that we again start at the origin. And in this case, you are moving at a constant velocity. We're not going to make you at rest. You're moving at a constant velocity like this. You know that that's a constant velocity because for every second in time, or every common duration in time, you're moving the same distance each time. Another way to think about it, if you're only in graph mode, is the slope of this line is constant, so I know the velocity has to be constant. So what is your slope here? We don't have numbers, obviously, otherwise you could do rise over run. We're just thinking about this qualitatively. The slope of this is positive, so the velocity is going to have to be positive. Okay? It's a constant velocity. For every second, this velocity stays the same. It's constant. Again, if we look at earlier what we were saying about acceleration, acceleration is how velocity changes. Well, we just said velocity was constant. If the velocity is constant and it's not changing, then there is no change in velocity. Then acceleration again is going to be 0. Okay? So constant velocity in the positive direction has a positive velocity, has 0 acceleration. Let's look at one more case. In this case, we'll start away from the origin. Doesn't really matter where we start for right now. In this case, I can tell that we have a negative velocity. We're moving in the negative direction. If down is in the negative direction, we're moving in the negative direction. The slope is constant, so the velocity is going to be constant. And because you're moving in the negative direction, you have a negative velocity. Now, is this velocity changing at all? No. No, the slope of this line is 0. The velocity stays constant. Since the slope of the velocity time graph is 0, acceleration is going to be 0. Okay? What did we just look at here? Let's look at all three of these graphs again. This one has a constant velocity. This one has a constant velocity. And this one has a constant velocity. This is a special case where the velocity is 0 or you're at rest. This one has a positive velocity, and this one had a negative velocity. All three of these cases are constant velocity. In all three of these cases, the velocity doesn't change. You remain going at a constant velocity the entire time. Whether the velocity is 0, positive, or negative, the velocity stays constant. And when you have a constant velocity, your acceleration is 0. Okay? Good, I think that's good. So here's constant velocity, acceleration is 0. Let's move on now to objects that are accelerating. All right, so we're going to start looking at objects that are accelerating. All four of these graphs are going to be objects with acceleration. And there are 4 unique examples here, but any combination of these could represent a figure in real life. Let's look at this first one here. I'm going to draw the line a little bit above the horizontal axis here so you can see what's going on. Okay. What is happening there? How could we describe this motion? We know it's accelerating because it doesn't have a constant slope. The velocity must be changing because the slope of this line is changing. To start out, the slope seems really flat. It almost has a velocity of 0. And then as time goes on, velocity increases. So what you end up with over here is a velocity that starts at 0. And then as time goes on, it's getting faster. This is like you're at a stop sign. Then you go, you hit the gas, and you're speeding up. And you're going in the positive direction. So it's increasing velocity in the positive direction. What is the slope of this line? Is that positive, negative, or 0? The slope of this line is positive. So the acceleration is going to be positive. That just means that our velocity is increasing as time goes on. So that's our first example. Second example kind of looks similar. In this example, we've got a graph that kind of looks like this. And in this example, what does your velocity start out as? The velocity here starts out really fast because this slope is steep. You're covering a lot of ground in just a little bit of time. And then as time goes on and this slope flattens out to 0, you're not covering very much distance or displacement here as time goes on. So your velocity goes to 0. So you have a really high velocity in the positive direction, and then you get a velocity of 0. So you're going really fast. It's like you're cruising down the road, and then you see a stop sign ahead, and you brake, and you come to a rest. Now, what is the slope of your velocity time graph here? Is that positive, negative, or 0? The slope of this velocity time graph is negative, and you're slowing down. Your velocity is decreasing over time, so you're going to have a negative acceleration. Okay, that's good, good. Let's just keep going along here, and once we see all of these, we can start to look at patterns. So let's see, we've done increasing in the positive direction, decreasing velocity in the positive direction. Let's do increasing velocity in the negative direction. That's a very poorly drawn line. There we go. So as time goes on, you start out going really fast in the negative direction. And then slowly over time, you end up at rest. Let's imagine this is a flat line here. So at first you're going really fast in the negative direction. You have a negative velocity. And then over time, your velocity becomes 0. Well, what does this mean for our acceleration? One way to think about it, which is kind of the cheating way, is what's the slope of the velocity time graph? Positive, negative, or 0? The slope is positive, so you would go like this. My problem with that is that maybe you don't really grasp it. You don't understand what it means. This means that even though the velocity is getting less because you're going to a velocity of 0, it's still increasing. It's becoming less and less negative. What this means is that you're slowing down in the negative direction. So that's why your acceleration is positive here. Let's look at our last example. We had this one, this one, this one. Last example looks like this. In this example, you start out at rest. Okay, so you're at rest, you're not moving, and then all of a sudden you get going really fast in the negative direction. So you're at rest, you're not moving, and then you end up going really fast in the negative direction. So you start out at a velocity of 0, and you speed up in the negative direction. This is your velocity time graph. What's the slope of that velocity time graph? The slope of that is negative, so your acceleration is negative. But another way for you to think about it is, how is my velocity changing over time? It's getting more and more negative. That's why my acceleration is negative. Good. So we've got 4 examples here, and I want you to look at all these examples and just kind of find some patterns. If we're looking over at all of the position time graphs, all of these position time graphs are curved. If there's ever a curved position time graph, that means that there's acceleration, okay? Let's look at all the velocity time graphs. All of these velocity time graphs have a slope that's not 0. So they actually have a slope. They're sloped. That's for the VT graphs, velocity time graphs. If they have a slope other than 0, that means they're accelerating. Let's look at all these acceleration time graphs. These are still flat. They're still constant. It's still constant acceleration. These are all constant acceleration. We don't want to get into the math of non-constant acceleration. But notice that none of these have an acceleration of 0. So they're all either a positive acceleration or a negative acceleration. If the acceleration is 0, then we have a constant velocity. Okay. So here's an example of all these graphs. I'll make sure to save this document on here. We did constant velocity when you're at rest, positive velocity, where you're at a constant velocity moving in the positive direction, negative velocities when you're in a negative velocity in the negative direction. Then you have acceleration. And in an acceleration, you're either speeding up or slowing down, and it could be in the positive direction or the negative direction. One thing I want to point out with the position time graphs again, especially these ones that are accelerating, is maybe you've heard this idea of concavity, concave up or concave down. Maybe secondary math 3, pre-calculus, definitely in calculus, concave up and concave down. If I have a function here, let's say this is a position time graph, this is a concave up function. Now if you look closely, we've seen these before. Where are these before? If we go back up to our acceleration, this one is concave up. That one's concave up. So is this first one we did. This is concave up. Now with concave up, one way to remember that is concave up, it makes a cup. What do you notice about these concave up ones? They both have positive acceleration. This one also has positive acceleration. So if you have a position time graph that part of it is concave up, that's going to have a positive acceleration. Now there's another type too. If you have a position time graph, it could be concave down. I remember this. Concave down makes a frowny face. Concave down, frown. This one's concave down. Let's look back at our position time graphs here. This one is concave down. This one is also concave down. both of these have negative acceleration. Okay, so concave down, negative acceleration. This one here was concave down, it also had a negative acceleration. So anytime part of your position time graph is concave down, it's going to have a negative acceleration during that portion. Now remember, in physics we start out trying to learn it in the simplest form, and then after that we try to get more complex. So in a lot of cases, these 7 that I just showed you, those are the simplest form, but we're going to get more complex. You could see a position time graph that maybe it accelerates, it speeds up, then it moves at a constant velocity, then it slows down and goes in the negative direction, speeding up, then it stays at rest, then it does this and this. It could do a whole bunch of things. And you have to break that up into pieces, because if you look at the whole thing, complex on the whole, it can be difficult. But if you break it up into the parts that you know, this part right here, this first part, this is accelerating in the positive direction. If you break those up into parts, it becomes simpler to understand. So this was my really quick summary of constant velocity graphs and acceleration graphs. I hope this helped. We'll keep doing practice in class. Let me know if there's anything else I can do to help you out. If you find any other videos that are worthwhile, make sure you send me those and a link, and I'll make sure to share those with the class as well. See you later. Have a good one.